Okay, I'll ask about this problem, let people work with them, everybody. All right. Now the reasoning is this is 2/3 divided by 5/8, which equals 2/3 times 8/5, which comes down to 16/15. So there's no way to simplify that. No way to reduce that fraction. Okay. Now that's with numbers, okay? What we're really getting into, because we're dealing with rational functions, or we're going to be dealing with rational functions. What we really need to do is understand how to do this with algebraic expressions. So let's say we got x plus 3 over x minus 5 divided by 2 over x plus 1. You apply the same procedure to that. And I don't know what's going on with the camera, but it's obviously confusing. Go ahead. Show the picture. Maybe it'll straighten itself out. Yeah, there it is. Well, the rule is identical to the rule you use up here. You just have algebraic expressions to deal with. Don't skip the step right out, the division sign and everything, just to be sure you get it right. Okay. Okay. Okay, well, it's recorded. Okay, well, that's basically recording. I thought I turn it over ahead. Okay, we have this divided by this. So that means the numerator divided by the denominator. Call this a complex fraction. You see that? So that instead of being, I'm going to write this as x plus 3 over x minus 5 divided by 2 over x plus 1. Just so you don't accidentally write that as a multiplication. And then when you divide by 2 over x plus 1, you multiply. By the reciprocal. So here's the reciprocal. We multiply, so we multiply numerators and multiply denominators. And you can multiply this numerator out, multiply the denominator out. But usually when you're dealing with expressions like this, you're better off to have them in rational and factored form. Okay, because right away, what can we see? If this is a function, what are its zeros? Okay, let's just see, let's just talk about that for a second. Okay, start again. We look on the denominator. And we can have I wrote it a little more coherently because this doesn't equal this divided by this. Don't use an equal sign if it is an equal. Okay, but your procedures. Okay. Okay. Now that's what you're doing. Looks good. Okay, just check. I'll do this in my head so you can correct me. Oh man. A lot of dead space in this thing because I'm forgetting to turn the thing off or something. Okay, well, it was recording during all that time. So when we do this, we're going to use a common denominator of 36 here. We're going to get 9 over 36, 28 over 36, which is going to add up to 37 over 36. Is that right? Okay. And here we're going to have a common denominator of 24. We're going to get 16 minus 15. Okay. Agreed. $37 over 36 divided by 1 over 24. That's 37 over 36 times 24 over 1. And I'm not going to, I actually got a good night's sleep last night, but I'm still not going to do that in my head. I just don't want to take the time. But it's somewhere around 40 times 20, around 800 divided by 36. And if you divide that out, you get something like about, I'm guessing 23 minutes. Okay. Now it's going to be a little more than 24. Okay. It's actually, I could just not figure that out. 136 those 2/3. But putting it set, well, actually, I'm going to do something here. I can write that as 37 times 24 over 36. 24 over 36 reduces to 2/3. So now I don't have to multiply these numbers. Now this illustrates why you want to reduce things when you can. Okay, and that gets into factoring. When you get into these expressions, you have to factor and see if anything divides out. But that's easy enough to do. That's 74 over 3. If I did it correctly. This also illustrates the fact that I really don't want to multiply these until I check to see if something factors out. Okay, that's all I'm going to say about this. I don't think you're going to have any trouble with it. Your fraction skills look pretty good. Just remember to do that step. You write out divided by, so it reminds you to invert your fraction. Okay. That's the biggest place where people make mistakes on this. Okay. Okay. Now here's really one of the more challenging things you learn to do with algebra. Hopefully you have algebra 2 skills that allow you to do this, but many people don't when they get to this course. Okay, so what I have to do to add two fractions is I have to find a common denominator. Okay, to find a common denominator, we do what I've recommended early in the semester when we were dealing with fractions. Multiply the numerator and denominator of this fraction by x minus 7 over x minus 7. In the first place, I can do that without changing its value. In other words, if I plug in any number for x, pick a number, any number, plug it in here and evaluate it, you're going to get a fraction, number divided by a number. If I do the same thing with this expression, I'm going to get exactly the same result. Because, of course, x minus 7 is going to be equal to x minus 7, whatever x happens to be. So this is going to be a number divided by itself, just 1. So it doesn't change the value of this. You're going to get the same value for this. You're going to get 1 for this. And it's going to be. Now, why did I choose x minus 7? Well, maybe because it's there, but let's see what happens. If I do this. Okay, so what's my denominator going to be over here? And my numerator is going to be this term on this fraction. It's going to be this. And the denominator is going to be x plus 3 times x minus 7. Over here, we're going to get x minus 5 times x plus 3. That's going to be divided by x minus 7 times x plus 3. My denominators are exactly the same. Well, what do you do when you have the same denominator? Well, the recording's on, so you can't answer. But if you were going to answer, you say, well, you add the numerators. And that's exactly what you do. Okay? So, here's what we have. That x plus 3 got compressed a little bit there. Should give myself more room, but I never do. So I don't want to surprise you. Okay. Now, what do you do with this? There's more to do. Now, over here, I said, hey, you don't really want to multiply these out. You want to leave them factored, okay? Because that's a fraction, simply numerator and denominator. It's factored. In this case, your numerator is the sum of two polynomials, and you're going to add those polynomials. Now, to add the polynomials, it means you use a distributive law to multiply this out, use a distributive law to multiply this out, and add them. I'm just going to do etc. here because you know how to do that. And then there's one more step. After you add these, you've got a new polynomial and you try to factor the blame thing. But it's going to be a cubic polynomial, lots of luck factoring it. Okay. Okay, so I'm going to give you one. I'm going to give you two, actually. I'm going to give you a fairly simple one. Okay. And then I'm going to give you one more like this. And I'm going to do subtraction. Give us a little variety. work on those. I'm going to run over to the printer because there's something I've printed off for you. And it'll actually be the midterm exam for this course, a sample. It'll be the major quiz for your pre-calculus course. So let me, okay, come on. Okay, everybody did quite well with this. Not everybody had a chance to do all the multiplication and simplification, so we're going to go over that. We'll do this one. I'll probably have to do this one on a different board because it's going to take a little more room. Okay. Okay, so plus 2. So I see first place that these match. They didn't a minute ago until I changed that minus to plus, and these match. And of course, this is the same as this. This is the same as this, so that I haven't changed the value of this or this. For any x value, if I do all this for that x value, do all this for that x value, I'm going to get exactly the same thing. Okay, now I multiply this out. So I have x plus 4 times x plus 2. And I'm going to skip the step where I write out the fractions separately. I know that I have the common denominator now, so I can write it out this way. And I know that I'm going to add numerators. Okay, y'all are talking fractions to the point where I don't really have to emphasize that fact, because I think everybody got to this point. And if you didn't get exactly what I got, you can look at it and make sure you understand what we're dealing with. And then I multiply this out. So I multiply this out using the distributive law, x times x plus 2 plus 4 times x plus 2, all that stuff. And I'm not going to put a couple of dots here. Steps that you probably should include, even though you're pretty well on top of this. Then we're going to get x squared plus 6x plus 8. And that's going to be plus 5x minus 45. I don't multiply out the denominator. And leave it back. Maybe in the last step I multiply it out depending on what I need. But I'm going to have to check to see if my numerator factors. Okay, after I combine everything. Probably won't, because I just made these up randomly, but it's possible that the numerator will factor. Now, in real life, it's impossible. The numerator never factors. But you're going to learn to do what you have to do for factors anyway, because maybe I'm wrong. Maybe you will run into a numerator in real life situation that actually factors, okay? It's rare, but it's still, you want to understand the nature of the function as well as possible. So we're going to check that. Okay, anyhow, we get then, we got a 6x and a 5x gives us an 11x. 8 and negative 45 gives us negative 37. So I'm even more confident that this thing is going to factor. Okay. Now, one of the possibilities for factoring this on real on integers would be like x minus 37, x plus 1, or x plus 37 and x minus 1. And either one of those is going to give us anything near 11 because 37 is a prime number. It doesn't break down. Then you got the rational roots theorem and stuff that we're not going to talk that much about because they're more important things. It's neat stuff. I wish we'd had time to talk about it. We're going to concentrate on what's important. So at this point, we pretty much know that the numerator doesn't factor on real numbers. And we could always plug into the quadratic formula. Because if the thing factors, then its zeros are going to be integers or maybe rational numbers. So just in my head, squaring 11, we get 121, and 4 times 37 is 148. Yeah. So we got 121 and 148, which adds up to 269. It's 169, we'd have 13 squared. And we'd be able to do the square root. Square root of 269, well, 269 is between 256, which is 16 squared, 289, which is 17 squared. So we know it's irrational, and you probably don't really need to know everything I just said. I'm not going to write it out, but there's things you can do to check. And the discriminant of your quadratic formula here gives you an irrational number. So this doesn't factor over the rational numbers. Then if we wanted to multiply this out, we get x squared minus 7x minus 18. Matter of taste whether you want to do that or not. Or it's a matter of what open math wants, whether you do it or not. Okay, we understand the procedure. We do a common denominator. We add the numerators. We expand the numerators. We add them up and see if they factor. Add up the terms of the numerator and see if the numerator factors. In this case, it doesn't. What's going to happen on some of the problems is your numerator will factor. And in some cases, one of the factors might match one of these. So you divide it out. Okay. That's called a removable singularity, but deal with that terminology when we need to. Okay, this one, it gets a little longer, but it's not a big deal. So we do just what I think I saw everybody do. We multiply numerator and denominator here by x plus 6, so we have a common denominator. That has each of these denominators as a factor. In other words, each of these factors is contained now in your common denominator. Okay, well, there we have it. And then we write that. That's to indicate this step you really want to include. Now you want to be careful, we got a minus here. So when we get to okay, so far everything's just like it was over here, we just have different expressions. Let's stay that way for a while. We multiply these out, we get x squared plus 13x plus 42 minus, and here's where you want to be careful, you put parentheses around what you get here. So x times x squared is x cubed. X times negative 4x is minus 12x. And you also 12x, negative 12x squared. And the negative 3x squared gives you a negative 3x squared. That's minus 15x squared. Now, if you understand what I just did, let me explain it a little more. There's only one way I'm going to get a cube of x, it's multiplying x by x squared. There are two ways I can get an x squared. I can multiply the x by the negative 4x, or I can multiply the negative 3 by the x squared. Well, I can put those together. I get a negative 12x here. I get a negative 3x squared here. Now, if you go step by step with the distributive law to make sure you're doing it right, you're not going to take that shortcut. You got to really be really confident with the distributive law before you start taking shortcuts. But some of you are pretty confident, so it's a little bit of a shortcut. However, I don't want to go to the extent of writing out the whole distributive law because I think you all are good on it. Okay, and then we're going to have x terms. Multiply x by 5, we get 5x. We multiply 3 by negative 4x, we get negative 12x. I believe that this is negative 7x. And then we just have our numbers, which is negative 6. So if you multiply these out using the distributive law, we can get this. Be careful to use the distributive law. Don't be taking shortcuts like you saw me do until you're really confident with the distributive law. Okay, and this is over then. Over this. So now we have what? We have a negative x cubed. Now again, when I want you to write it out, give myself a little room to write 3 lines. What I want you to write it out is do the distributive. You get a negative x cubed and a positive 15x squared and a positive 7x and a positive 15. I'm going to do it methodically. It'll save you time in the long run if you're at all prone to making mistakes. Okay. So 3 dots we get. And also, think before you write one. No, I don't. Okay. So we got this. What do we have on x squared? We've got an x squared and a negative of a negative 15x squared. That's a plus 15x squared. So I think we've got 16x squared. 1 here and plus 15 here. And then 13x and minus a negative 7x is 13x plus 7x. That's 28x. And then 42 minus a negative 15 is plus 15, that's plus 57. All this is divided by this. Now we try to factor, we try to find a number that makes all this 0. Okay? Because if we find a number that makes all this 0, we can do a long division by x minus that number. Not going to have to worry about that too much for right now. But I see that, yeah, we're actually, okay, like if x was equal to 1, well, that wouldn't help much because it's pretty clear we've got 3 positive numbers here and only 1 negative number, and the negative number is not very big. If x is 1, this is not going to equal 0. Okay, but we asked around. We check maybe x equals 1, 2, even 3, or negative 1, or negative 2, or negative 3. You see if we get 0. Not likely to work out. But just in case, we want to factor the denominator. Is there anything you can factor in the denominator? Well, almost. It was x squared minus 4x plus 5, then x squared minus 4x minus 5. That would have factored into x minus 5 and x plus 1. Okay? So you want to check the quadratic to see if it factors. You can always do the discriminant. Square root of b squared minus 4ac. If that's something that has a square root, you know, it's an integer or a rational number, then you're going to be able to factor. And if you have a factor in the denominator that matches the factor in the numerator, again, you divide it out. So that's the last step. You get everything up to the last step in good shape. And then, at least as far as the assignment, and of course, the assignment on this is not going to be due until Monday night. So you won't have to do it before we come back again. So I'm going to recommend that you take a look at that assignment, work on it a little bit if you have time, and see if any questions arise so we can deal with them in class before we have to do it. We'll do at least one more example. But we do want to then move on into graphing these things. And I showed you a little bit about how we graph them. So I'm going to say a little more about that because y'all are moving really well with this stuff. Your fractions are good. You understand the procedure. I think you're going to be in good shape. Okay. So the harder thing is graphing them. So let's look at how that works. Okay. We'll talk about how to graph this. We talked about graphing a little bit on the example I did here. You see a little bit of it here. And you probably picked up on quite a bit of that. But let's just talk about what you want to do here. Could have recorded. Okay, so looking at this function pretty quickly, got two things. One is maybe kind of reciprocal squared thing going on in here. Okay, and that's a really good observation. It's not quite right, and you'll see why. But just looking at it in terms of your basic functions. Okay, so I really like to hear that. Okay, there's an easier thing, which is if x is -3, it's 0. If x is 2, it's 0. Okay, so now we can put 2 points in the graph and we're off and running. All right, now there's another point on the graph that's really easy to find. Okay, the hint I gave everybody is first thing you look for when you have a function is you look for the axis intercepts. We found the x-intercepts. Okay, there's no other number we put in that makes the numerator 0. And the numerator has to be 0 to make this whole thing 0, no matter what the denominator is. So how do you find the y-intercept? I simply keep track of when I'm recording and when I'm not. Say all that real quick. We're finding the intercepts. The zeros are the x-intercepts. They occur when y equals 0. You can set this, if y equals this, you can let y equal 0, you set this equal to 0 and solve the equation. Multiply through by the denominator, it kind of disappears, but you got to be a little bit careful. And then you could immediately get that solution, but you can just do the final solution. Okay. The y-intercept occurs when x equals 0. Why? Because y-axis is a set of points where x equals 0. Wherever the graph goes through the y-axis, the x-coordinate is 0. So we put in 0 for the x-coordinate, and we very easily get the x-intercept or the y-intercept 6/5 or 1.2. So here it is. So I'm not going to label that just now until I see where the graph was. Actually, I kind of can. I think I'll show you what I'm doing here. So we're already getting a lot of information about the graph. It's a polynomial, maybe come up through here, down through here, then you'd have to go up again, so you don't have another place in the x-axis. Maybe you come up through here, over here, and just kind of do a parabola type thing here and going up. Okay, but it's not a polynomial, so you're not even going to think about doing that. Unless you love polynomials so much, you just can't help yourself. Okay, now the next thing we need to do, well, I'm going to give you a chance to tell me. This is new to you, so you might not have sorted it out. Okay, well, we had an interesting discussion. We're going to look for asymptotes. You're out of time. Well, and interesting discussion, honing in on what basic function has asymptotes, okay? Well, the reciprocal function, well, why does that have an asymptote? Well, because you can't cross the y-axis. Why is that? And dot, dot, dot. And finally, asking a couple of questions. Well, yeah, because the denominator can't be zero. That gives you the asymptote. Okay. If the denominator is zero and the numerator isn't, okay? Well, wait a minute. That factors into x minus 5 and x plus 1. So it should be -1. It's -1. And -1 plus. Okay. I did something in my head, but I finally honed in on the right. Okay. You can factor that. Factors is x plus 5, x minus 1. So you immediately get your zeros at x minus 1 and x plus 5. So you have an asymptote at x equals -1. A vertical asymptote. And also at x equals 5. So you check the long run behavior, okay? X is a big negative number. Well, this is going to be positive. This is going to be negative, and this is going to be negative. So you have a negative divided by a positive. So it's going to come down from here, go through here, and then come toward your asymptote. And then on the other side, it's going to come down through here and do this, except the long run behavior on the right doesn't match that. Well, anyhow, it does stuff like this. You find the intercepts, you find the asymptotes, and you do a couple of other things we don't have time to do. We'll pick up on them. So if you understand that much, you're off to a good start. I'll just tell you what else you do. And what I just said about the long run behavior, of course, it's not right. In this case, you got a negative here, a big negative here, you got a big negative here, and they're equally big. If x is a huge negative number, it's like you got an x squared up here divided by an x squared down here. So that means that you've got a horizontal asymptote at x equals 1. I said that fast. But that's the way it works. It's going to look like all of this. And there's more. I'm going to take the time to do it. Maybe pick up on it next time. Some of them might not be completely right. Work it out, see.